All right, friends, today in class we talked about points on a number line. And so in class today we looked at 2 and 1/10, the first activity, and we talked about what of the following numbers could be B. Most of us understood that 2 and 5/10, 5/2, and 25/10 could be B, but then we talked about whether or not 2 and 49/100 could be B as well. And because there are no intervals on this number line, that tells us that it could also be 2 and 49/100. I then asked the students if they could tell me what these numbers had in common. And most people told me, well, these were improper fractions, but they weren't getting to the point that I really wanted them to understand, is that these three are equivalent. And you should understand that. You should see them and see them as equivalent numbers because they all equal the same thing. Please also understand that a fraction also represents division. It's also a ratio, something that you need to understand, right? And that was for the first activity. In the second activity, I asked students to identify the temperatures on these scales in A, B, C, and D. And in E, I asked students to find the interval, or I asked them to find out what it is counting by. So in A, we determined that this is 1 degree Celsius. In B, we determined that this was -2 degrees Celsius. And this one, we determined that this is 3.5 degrees Celsius. And in D, we determined that this is -0.5 degrees Celsius or 5/10 degrees Celsius. And on here, we figured that this one on E is counting by 5. And what someone pointed out in class is that 0 kind of acts like a mirror on a number line. So you basically get numbers equal distance apart, which I thought was a great metaphor for understanding the activity for this. So once we get this, we get to number 2, and it has us read a number line that's not currently present here, but the number line basically, the thermometer, and I'm going to draw it here, that the picture reads that this is 0, this is -1, this is -2, and it reads, it's asking what the location is of this little thing that I'm drawing there. I'm going to shade that in. And basically it's arguing between Elena, who says that that's -2.5 degrees Celsius, and Jada says that that's -1.5. We determined that Jada is correct because -1.5 should be between -2 and -1, because 2.5 is farther away from 0 than -1.5. So we also talked about this understanding that that the further away a negative number is, the smaller the number is, which is an important thing to take away. See, intuitively we know a lot of math, but we need to understand the depth and the reasoning behind what it is that we know. And this last question for this activity is, one morning the temperature in Phoenix, Arizona was 8 degrees Celsius, and the temperature in Portland, Maine was 12 degrees cooler. Well, for this problem, I'm going to write 8 minus 12, which we talked about this yesterday. We talked about what would this be if we know that 12 minus 8 is 4. Then taking that information that we have here and flipping the numbers around would just mean that this would be -4. So this would give us the opposite answer of that, of 4. We would place a negative because the 12 is greater in, a greater subtrahend here. So that's what we found out yesterday, and we're just applying that knowledge today. So this is -4 degrees Celsius, and I need to draw that C larger. In the third activity today, we actually made a number line using tracing paper, and I should have some tracing paper here. It looks like I might have not picked up some tracing paper, so I'll be just a second to get that tracing paper. So I want to make sure that people understand how to do this number line. And so with this is, we're going to take some tracing paper, we're going to take a ruler, and what we're going to do is we're going to follow the instructions on this thing up here. So On this, it tells us that we're going to take a ruler, and it says use a straight edge or ruler to draw a horizontal line, mark the middle point of the line, and label it 0. So I'm going to read further down. To the right of 0, draw tick marks that are 1 centimeter apart. Label the tick marks 1, 2, 3, all the way to 10. So because of this, I'm going to draw a line, a horizontal line, that is actually greater than 20 because I need to have 10 centimeters on both sides of it. So I'm going to draw a line to 21. The second thing it asked me to do is it asked me to find the midpoint. Well, if I have 21 and I've cut that in half, the midpoint would be 10 and a half. So I'm gonna put 0 there. Then the next part of the directions ask me, right? So they asked me to measure from there 1 centimeter apart. And so I'm gonna put the tick marks or the intervals and put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this side is the positive side of the number line, so I'm going to label that positive. And what it asks us to do next is that we're going to fold our paper so that the vertical crease goes through 0. So I'm going to fold the paper on 0. I want the crease to go straight through 0 so that you have one line that does something like this. And so you can kind of see that I've labeled those numbers, and it's almost, perfect. It might be a little off, but the idea is that it's like that mirror that student suggested. So I'm going to mark these tick marks. So when I open this back up, right, it should reflect that. So I'm going to put -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10. So that's what we did as an activity in class, and this side represents the negative side. And what we're using from this is we're understanding how far away some of these, so you can see that my number looks a little off there. We're trying to see equal distance from 0. That's where we're going with this activity. So the questions that correlate with this is that we're going to now use our number line to answer these questions. So which number is the same distance away from 0 as is the number 4? Well, here's number 4. That's 4 units away from 0. And this is, so I need to find the number on the opposite side that's also 4 units. Well, I see that -4 is that. So -4 is 4 units away from 0. Which number is the same distance away from 0 as is -7? So that is 7 units away. So the opposite of that is 7. And then it tells us 2 numbers that are the same distance from 0 on the number line are called opposites. Find another pair of opposites on the number line. So we did talk about in class that 0 is its own opposite. So if I put 0, the opposite of 0 is 0. So -1, +1. -2, +2. Those are opposites of each other. You could have picked anything. So determine how far away the number 5 is from 0, then choose a positive number and a negative number that is each farther away from 0 than is 5. So we're looking for a number greater than 5. Well, a number greater than 5 is 6. The opposite of 6 is -6. Determine how far away the number -2 is from 0, then choose a positive number and a negative number that is each farther away from 0 than is -2. A number greater than -2, a number that is farther away, so we can't think about it as greater. So a number that's farther away than -2 is -3. The opposite of that is 3. They're both farther away. It's not necessarily greater, so I have to fix my thinking there out loud. And then on the back, we got to this problem, which did stump a few kids. So really, you're taking this number line, and what I want to do here is I actually want to trace this number line with my tracing paper. Because this will help us determine the best possible answers for this. So I'm going to just trace it, so I can match up like we did in our previous activity what these are. So I'm going to fold this. So I want to mark 0, so I can fold it right on that crease. I'm going to mark 0. So I'm going to fold it right on 0 like I did at the last one and hope, I guess I also need to indicate where those points are. That will help me, right? So I'm having a rough time doing this out loud and thinking ahead. I want to try to match up these points with numbers over there. So I'm going to fold this now and hope that it cooperates. So there is 0. So if you look at that, that looks like this gives us a pretty exact sort of thing. So in class, we talked that these things, right? So if I fold it right on 0, I can see that it looks like 2 is P. So P equals 2. Looks like 4.5, maybe 5 for X. And then Y is 7.5, which some kids got pretty close to those numbers, not using the tracing paper. So that was today's lesson. The end goal of today's lesson is that we understand this term opposite and what opposite means. So we want to understand that an opposite of a negative number is a positive number, and the opposite of a positive number is a negative number. Every number has an opposite, including fractions and decimals. So, you know, if I ask you what's the opposite of 3/2, you should know that it's negative 3/2, right? Nothing, you know, I can ask you anything like that, and that's fair game. And we need to understand what rational numbers are. And so from this as well, so we have opposites, and then we have the term rational. So rational numbers are any number that can be written as a fraction, or the opposite, right? So any number that can be written as a fraction or the opposite of that. It has the word ratio in it, so it should help you understand that it does involve a ratio, and ratios can be written this way. So that's how that helps you understand what is a rational number. If it cannot be written as a fraction, it's not a rational number. So that's what we did today in class. I hope that helps you when you're studying. I hope that helps parents to kind of help their students. I hope that all this information is helpful.